Today's problem is to find the longest common substring in a given two strings. From the calc problem, the given two strings are A, B, C, D, X, Y, Z, and X, Y, Z, A, B, C, D. So these are the two strings. So these two are the common substrings, that is, and these two also common substrings. But we need a longest common substring. This is A, B, C is the longest common substring, and the length is 4. So generally these kind of problems we use a dynamic programming. Dynamic programming is nothing but storing the results. We are just, let's take a DP table and start explaining it. For suppose A, B, C, D, X, Y, Z on the row side and X, Y, Z, A, B, C, D on the column side, we start comparing the character of a first string with the other characters of the second string. So this means A from S and X from S2 string, and this cell means comparison between A and XY, and this cell means comparison between A and XYZ. So this particular cells represents these particular cells represents the comparison is between A, X, Y, Z, A, B, C, D. Similarly, when it comes to this part, this cell represents the comparison is between A, B, C, D, X, Y, Z and X, Y, Z, A, B, C, D. So this cell represents, we are comparing the strings, the whole string. So whatever the result we get here will give us the length of the common substring. So how we will reach this point and how it is returning as a maximum length of the common substring, we will see that. So let's start from the very beginning. Let's take an A, compare it with the X. Is A is X matching? No. So what is the common length between the two strings A and X? It's 0. And then compare A and XY. X, Y and A. What is the common length? So A, we already compared with the X and now compare with the Y. Still there is no match, so 0. So similarly here 0. Now here A is matching A. That means comparing the A with X, Y, Z, A. So what is the length of the common substrings? A, 1, right? So we just write 1 here. And then similarly B, it's not matching, and it's not matching, it's not matching. Done, first row is done. Next come to B, and again. So when it comes to B, what is the matching pattern? So AB is the string and X is the string on the other hand. So what is B is matching with X? No. With Y? No. With Z? No. With A? No. With B? Yes, it is matching, right? So what is the number that we need to fill here? So AB is the string this side and XYZ AB is the string the other side. What is this? AB and AB are matching. How we are representing here? So when we go diagonally, so these two, it's already matching. So whenever we see a matching character, we need to check the diagonal value of that particular table. If it is 1 or 0, whatever, we just need to add 1 to that, because here in this case we have 1 here. Even if it's A and it's some, if this is A and for suppose this is something K, it is not matching, 0 will be there. But still when we see any matching character, we just go to the back and see what the value, that is called a backtracking. We'll go back and see what is the value in the diagonal, so that we just add 1 to that. So here what is that? 2. That is true. AB are matching, the length is 2, so this is 2. And again BC 0, BD 0. Next come to the C. 0 0 0 0 0 and C is matching here. What is the value diagonally? 2. 2 plus 1 3, right? And then C does not match D. Now D comes. It's not matching, not matching, not matching, no match, no match. Here it is matching. Go diagonally. It's 3. So it will become 1 plus 3 4. Next come to the X. X and X are matching 1. So this is one more condition. Either a row or a column is 0, then there is nothing that we need to go diagonally, right? So that is a one more edge case. If either the column or a row is 0, then if we find the match, then we directly say it's 1. We don't go diagonal and add because there is no diagonal element. That is the starting position. So we just directly say 1 here. And here 0 0 0 0, and then y 0. And now here this is not, so this is one position, 0 1 2 3 4 5, this is fifth position, so nothing is 0 here, neither a nor y, neither I nor j. So we have to go to the diagonal. 1 plus 1 2, and again no matching, so all zeros. Come to the z. This is 0, this is 0, and it is matching. Go diagonal. This is 3. 0 0 0 0. See, I said what is the value here is 0, but what is the maximum, that is, so in this case for this particular problem, not every DP problem will result into the result value to the end of the array. It is that based on the problem, how we extract the required result is matters. In this case we need a maximum, so here we got a maximum. So it always needs to maintain a variable to keep track of the maximum. So here in this case the maximum is 4. So when we code it, I'll clearly explain how we can keep track of the maximum value and keep changing it. And also we need to keep track of the uh, characters that are matching and that they are subsequent. So here in this case A B C D and XYZ both are there, right? But we need to return ABCD because ABCD is the maximum that we find. So how we keep track of this particular string is also we will see when I code it. So this is the approach how we find the common substring of the two given strings. I'll code this out now. Okay, I'll name this function as common substring. So let's make it as a static function, and it's going to return as a string, and when we return the common string we can retrieve the length of that. So whatever is the ask, according to that we can return. So string common substring, we will give in two strings. Let's take out the lengths. Lengths of two strings here. And then to keep track of the maximum, initially the maximum should be very less. Generally the length will never be negative, so I'll just make it as -1, so that in the comparison the initial max is always a negative, right? mm, so, and also to keep track of the strings, I'll just, because there may exist more than two strings which are of the same length and they are of maximum. So to keep track of that, I'll just have a list of strings as results, and initially that is null. And let's initialize a two-dimensional array called match. Okay, the initializations are all done. Let's start the for loop. So by the way, the time complexity would be m by n, and with an extra space of mn. Hmm. This is the first for loop, and the next one. So once we start the for loops, what is the first thing that we need to do? We need to check, is the are the characters are matching. If they are matching, then the functionality. If they are not matching, then the value in the cell will be filled with a 0. So as we see, there is no match we are filling here. We are filling is 0 here. So we need to check that first. So are these characters are matching? If they are matching, and as we said, if either column or row any of them are zeros, we directly say 1, because there is no diagonal element to that. That is the starting. That we need to first do that. If I equal to 0 or j equal to 0, we just fill that particular cell with 1. Okay, else what we'll do, we just go to the diagonal element and add one more. How we go to the diagonal element? We just decrement the row and decrement the column with the 1. So this is one case. Now this is all done. Now we need to check, is this match value, that particular cell value, is greater than a maximum or not, right? So then we need to replace the maximum there. We'll just assign that match, that cell value, and we need to keep track of the results also. So every time we see the maximum is changing, the result set will be changed. So the result set will be new. So because till now we see the maximum is 2, and we have 2 or 3 strings added to the result set, and we found the next matching character, and now the maximum became 3. So we need to arrange all the results we stored in the results list till now, and start adding the new maximum string. So that's why we'll just initialize it to the new list. And you just need to add it. Now how we add, how we backtrack, that is the one thing that we need to see carefully. How we are adding, from which character we need to backtrack. So this is the value. So how we came to here, substring. So we are here, right? And now how far we need to go back? As the max is 4, that means 4 characters are matching till this part. That means these 4, How we are going these 4? So we need to go till here. So when you see here, so what is the index value? 0, 1, 2, 3, 4, 5. So this is, so what is that? I is 3. I is 3 and max is 4. And how we can retrieve? When I is 3, 0, 1, 2, 3. We need to go to the 4 characters back. 1, 2, 3, 4, 4 characters back. So we came to 0. How we are coming to here? So the simple math is, how we obtain, how can we obtain? So if you see, I minus max plus 1, it gives us 0. So this formula would work no matter what, wherever. So see, if for suppose we want to find from here, so what is this? Max is 3, right? What is I? 6. I is 6. We need to go to 4. So 3 characters back. I is 6. 6, 5, 4. We need to till the 4. How we can get the 4? 3 minus 6 plus 1 minus 3, sorry, 6, I is 6, right? 6 minus 3 plus 1. So this is 3 plus 1, 4. See, we went to 4. So this is the formula that is true in every case. That is the reason why we start here. And what is the length? Max is the length. So we just give the length here. Substring of I minus max plus 1 max gives us the actual string, right? This is the calculation. Now, what if it is equal to the max? We just have to add that to the results. So, else if match of ij equal to max, we just add the same. We don't declare a new string here. We just keep on adding to the list. String I minus max plus 1 comma max. Now, this is done. This is done. So till this part, this if clause is closed now. What if it is not matching? For that, else we just fill the cell with 0. Now all the for loops are done. This for loop is done. This for loop is done. Whatever is there in the results, we return. As we have to return only one, anything is fine. So it will be results of 0. I'm just returning the first one. So once we return that, we'll get the common string. For suppose in this case A, B, C, D is the maximum common string. If we were asked the length, you just have to retrieve, for suppose string dot length will give us the 4. That's it.